Okay, so we're moving on to the second half of the intermediate paper 2 numeracy from the summer of 2017, and we're moving through to the grade C and grade B questions on this paper. So question 10. Mali's scooter depreciated, which means it decreased in value by 24% in the first year. In all other years, her scooter depreciated by 13% of its previous year's value. She originally paid £850 for her scooter. Calculate the value of Mali's scooter after 10 years. So that's what we have to do. That's my question. Now this is in the second half of the paper, so it's not entirely straightforward. And we should recognise that it is a compound percent question. So that's the aspect that you'll be revising. First thing we do is work out what the multipliers are. We start with 100%, and if something decreases in value, then it's going to lose 24% of its original. So for the first year, the percent multiplier we'll be using will be 100 less the 24, which is 76%. And then for the other 6 years, the percent multiplier will be the 100%. It's still losing value, so we're going to subtract 13%, which is 87%. So the way that we've practiced using our scientific calculator to answer questions like this is we take the value 850 and we multiply it by the first multiplier, which is 76%, to the power of how many years it's being reduced by that. So that would be to the power of 1. And then for every year after that, it's being reduced by 87%, and we've got 6 years at that. We don't need to put the 1 there, but I think it helps because we can see I need to cover 7 years, and I've got 6 and 1 is 7 there. So on our scientific calculators, we can put that in exactly as we've written it. So 850 times open bracket 76%. If you've learned percentages by turning that into a decimal, you could put 0.76 in there rather than the 76%, to the power of 1, and then times open bracket 87%, and that's to the power of 6. And press equals, and you get to that string, which it's pounds and pence, so we round to 2 decimal places. We're going to have 280 pounds and 12 pence. Okay, and then the marks for that will be 2 marks for the method of however you are breaking down the 2 stages in the reduction, and an answer mark for the 280 pound 12. The crucial thing is recognizing what aspect of percentages you need to deal with there, which is compound. Sanjay stacks 3 boxes in a pile. The heights of the boxes are 25 centimeters, 36 centimeters, and 47 centimeters. They are all measured correct to the nearest centimeter. What is the greatest possible height of the stack of the 3 boxes? Now, on first glance, this looks ridiculously easy because I just need to add those 3 values together. Bearing in mind we're in the grade CB part of an intermediate tier paper, clearly there's more to it than that. And the trigger here that you need to look for and be expecting this question is the fact that they're measured correct to the nearest centimeter. So if you have 25 centimeters, because that's rounded correct to the nearest centimetre, anything 24.5 or above will round up to that, and anything up to 25.5 will round down to that. So that has got a maximum and minimum possible value, as have the other two. That maximum would be 36.5 and minimum would be 35.5, and the 47 could be up to 47.5 and down to 46.5. So if I want to get the maximum possible height of the stack, I will be adding together their three largest values. The question asks for the minimum possible height, I'd be adding those three. So the actual sum that you have to do is that. So when we add those together, we get so 109.5 centimeters. So it's still a particularly straightforward piece of arithmetic we have to do, but unless you spot that trigger, you won't get the marks for that. So for the marks for that, you're looking for 1 mark, so long as I see that you're recognizing you're working with maximum and minimum values, and 1 mark for the final answer. Question 12. Ursula is lying on her surfboard 180 meters away from the foot of a vertical cliff. The height of the cliff is 146 meters. Ursula was told that if the angle of elevation of the top of the cliff from her lying position is between 42 and 45 degrees, it is safe for her to attempt to stand on her surfboard. Calculate the angle of elevation of the top of the cliff from Ursula's position lying on her surfboard. So that's something we have to do. And then we also have to say whether it is safe for her to stand, not safe because she's too near, or not safe because she's too far out. Right, so let's find that angle first of all. And I can see here that what I'm working with is a right angle triangle, and the angle of elevation from her lying position is that angle there. So I'm thinking trig. If I've got a right angle triangle, it's either Pythag or trig. If I'm trying to find an angle, it has to be trig. So looping back to my formula that I added on the front, that's this SOHCAHTOA. So I need to label my sides. The hypotenuse is the one that's always pointed to by the right angle. The opposite is what's pointed to by the angle we know or we're trying to find, and the adjacent, the one that left. So if I want to find an angle, I need to have both of these sides, which is O and A. So the one that links O and A is tan. So I'm going to write that back over here. When I'm trying to find the angle, it's the T that I cover up. So tan of the angle is O over A. So tan of the angle is O, which is 146, over A, which is 180. And then to get the x on its own, we have to do the opposite of tanning. Now if you look at the sine, cos, tan buttons on your calculator, you'll see that above them you've got their opposites: sine -1, cos -1, tan -1. So I want tan -1 to find the angle of 146 over 180. I can put that into my calculator exactly as I've typed it using the fraction button. 146 on top, 180 underneath, close bracket. That comes to 39.0 degrees. So I've worked out that that angle there is 39, which has answered that part of the question. Now for it to be safe, she needs to be between 42 and 45 degrees. So it's not safe but we then need to be clear about whether it's not safe because she's too near or she's not safe because she's too far out. Now, as you move closer to the cliff, the angle of elevation becomes steeper. So if she is 39 degrees, she's less steep, which would be further out, because the further out you are, the narrower that angle is going to be. So she's not safe because she's too far out to sea. So the marks for that, there's 1 mark for the tan x is 146 over 180. There's an extra method mark for the inverse tan, and an answer mark for 39 degrees, and then your explanation mark for saying not enough just to say not safe, you have to say that she's too far away. Question 13. Marta buys a new television. She wants to fit the television in a bookcase on the wall. In the shop, she forgot to write down the length of the television. She did write down the height and the diagonal of the screen. Marta needs to know the length of the screen before she opens the box, in case she wants to return the television. Calculate the length of the screen. Give your answer corrected to significant figures. So there's 2 instructions there that we have to answer. Now, I've got a right angle triangle again, which I can see there. So I'm going to lift that out of the picture. So I'm just working with a nice straightforward. It's a right angle triangle. It's in the CB part of the question, so it's Pythag or trig. I've already done a trig bit. With this one, I don't know anything about the angles, and they're not asking me for the angles, so we're actually working here with Pythag. When you work with Pythag, you know you need to square the sides. So 44 squared, 1936. 16 squared is 256. The next decision you have to make is whether you're going to add or subtract those squares. Go back to the context of the question. If you're trying to find the larger side, then you need to make the outcome larger, so you'd be adding. The larger side is always the hypotenuse, which is pointed to by the right angle. So that's the larger side. I'm trying to find the smaller side, so I need to make the outcome of that smaller. I need to subtract. So 1936 take away 256 is 1680. And then I don't want to work with squares, I want just the length of the side, so I have to do the opposite of squaring, which is square rooting. So I square root my 1680 and I get that string of decimals. Now, because there's an additional mark for rounding here, I'm not going to write that down straight off unless I'm really confident with significant figures. So to make sure that the examiner can see that all my work up to this point is correct, I'm writing down that nice long string of decimals. My Pythag part of this is then right. I just need to then deal with the significant figures. When you're rounding significant figures, you start counting immediately you're into the number. So that's my most significant because it's in the tens column, and then that's my second most significant. So this number is between 40 and 41 to 2 significant figures. You look at the next digit along, it's a 9, which makes it closer to 41. So to 2 significant figures, you have 41 centimeters. Sorry, which I've just written down there. 41 inches. So marks for that. There's a method mark for squaring and subtracting and square rooting. So the whole Pythag package, squaring, subtract, square root, gets you the method. And there's an answer mark for the full correct string, and then there are actually 2 marks here for rounding to 2 significant figures. So that's a skill they're really testing there. Part B. The television was reduced in the sale by 26% of its original price. It cost Marta £710.40 in the sale. What was the original price of the television? Now, if you don't stop and think carefully about this, you will make the most common mistake seen, which is, all right, so if I find 26% of that and take it off, that will give me the original. That would not be tested in the second half of an intermediate tier paper. It's too easy. So you have to be looking for this reverse percentage question. I know what it was after the reduction. Now, the percent multiplier here, it's been reduced by 26%. So the original is 100, less 26% will be 74%. So the original value cost, if I multiply that by 74%, it gives me the reduced price, which is what we know. So the original is what we're trying to find. If we multiply that by 74%, it gives us the value we know. So we have to work backwards through this machine. And when you work backwards, you do the opposite. So instead of multiplying by 74%, I will divide by 74%, and that will give me the original value. So on my calculator, 71040 divided by 74%, or 0.74 if you like working in decimal, and you get £960. Now you can check by using the sort of grade D skill. If I find 26% of that, and take it off the 960, I get the £710.40. So I know that I've got that right. So there's a method mark for 71040 divided by 74%, or 0.74, however you are comfortable writing your percentage, and then an answer mark for the 960. Part C. A television uses 1 unit of electricity every 10 hours. A unit of electricity costs 9.8 pence. Calculate the cost of having a television turned on for 24 hours. So every 10 hours costs 9.8 pence. So I need to find out how many blocks of 10 I've used. So the number of units will be 24 divided by 10, which is 2.4. And each unit costs 9.8 pence. So that's what I'm going to do on my calculator. £23.52. Now, where you have to be careful is with the units here. I'm working in pence, so that's in pence. So the temptation to put a circle around £23.52, you have to be careful. I'm working in pence, so it's actually 23.52 pence. On average, Marta watches 4 hours of television each day. On average, how much a week does it cost her to watch television? So there are 7 days in a week, so the number of hours will be 7 days, 4 hours a week, 4 hours a day, 28 hours. Get that back to the same as previous then. Number of units will be 28 hours divided by 10. which is 2.8. So the cost will be 2.8 lots of 9.8 pence. So my answer will be in pence again. 27.44p. And once more, they're being cruel there by giving you the temptation of pounds. 1 mark for each of those. Question 14. Aileen's old fish tank is leaking. The old fish tank is in the shape of a cuboid. The base of this tank measures 60 centimetres by 40 centimetres. Before the leak, the height of the water in the tank was 45 centimetres. Aileen decides to replace her fish tank with a cylindrical one. She selects a new cylindrical fish tank that has a radius of 25 centimetres and a height of 70. Will the original contents, including the water and the fish, fit into the tank? You must show all your workings. So I'm seeing here a cylinder. I remember that I wrote down, if I can find my formulae, the volume of a cylinder there, pi r squared h. So where that's h, and that's the radius. First of all, I can work out the volume of water in the original tank. So for a cuboid, that's length times width times height. So 108,000 cubic centimetres. So I now need to work out what the volume of this cylinder tank is to see if it's a bigger value or a smaller value than that. Pi times r squared times 70. I can type that in exactly as I have written it. Shift and times 10 to the power of gives me pi times 25 squared times 70. SD it, and 13,744.6786 cubic centimetres. Well, that's approximately 137,444, which is a bigger number than 108,000. So yes, it will all fit, because 137,444 is a bigger volume than 108,000. Marks for that. 1 mark for the volume of the cuboid. A method mark for pi times 25 squared times 70. Answer mark for the correct volume, and an explanation mark for yes, and showing that you're comparing those two capacities, those two volumes. Question 15. Simon plans to make gloves. One morning, Simon decided to carry out a survey to find the mean handspan of people in Wales. He decided to sample systematically. So that's a trigger. In the intermediate tier, that's the main type of sampling that we need to know about. he decided to sample from the first 240 people who pass him in the street during the morning. He wanted to take 20 people handspan measurements. Explain how Simon could use systematic sampling to obtain 20 measurements. So the stages that you have to write here is, first of all, how many groups of people he needs to ask. So 240, how many times does 20 go into 240? So 12 groups. Then you say, select one person at random from first group, and then every 12th person. So to get that mark, you have to do that division to find out how many people you're going to stop. So you're going to count every 12th person, but in the first group of 12, the first person is picked at random. So if the first person was the 4th, you'd ask the 4th person, then every 12th. So it'd be the 4th, the 16th, the 28th, etc., etc. 1 mark for that. Part B. Yesterday morning, Simon only managed to sample 10 people. He calculated the mean handspan of these 10 people to be 22.8. Yesterday afternoon, he recorded the handspans of a further 20 people. The results for these 20 are shown in the frequency table below. Calculate an estimate of the mean of all 30 handspans. So I've got 10 people in the morning, and I've got these people here. So I want to be working out a mean out of 30. As soon as you see in the second half of a calculator paper grouped data like this and the estimate of the mean, it should trigger with you, oh, I need to work out the midpoints and so on. So that's exactly what you need to do. So the midpoint halfway between there and there is 20.4. Halfway between there and there, and if you're not sure, if it's not logical, then you can add the two together, press equals, and then divide by 2. So add them together in half, and you get 21.3. 21.8 plus 22.6, press equals, divided by 2, 22.2, and then 22.7, 23.5 divided by 2, 23.1. So these two people in this category, I'm estimating by saying they're both approximately 20.4. So then I multiply those together. So 20.4 times 2, 40.8. 21.3 times 3, 63.9, 22.2 times 10, 222, 23.1 times 5 equals 115.5. So then I work out the total of the 20 by adding those together. And I get 442.2. Now I don't want to work out the mean of those 20. I want to find out what the total is of the first 10 and add it to it. So for first 10 people, the mean is 22.8. By multiplying that by the 10, it'll give me the total. So the total for the 30 will be the 442.2 plus for 228, which is 670.2. So that's the total of all 30. So the mean of the 30 will be the total divided by the number of people there are, which is now 30. So that comes to 22.34 centimetres. What could Simon do to improve his estimate? Well, whenever you're gathering data, to make it better, you gather more data. So ask more people, increase the sample size, gather more data, something like that. Okay, we've got 6 marks here. There's 1 mark if I see sight of the correct mid values. There's 1 mark for multiplying, and there's 1 mark for me seeing the total of those 20. There's then a method mark for realizing you need to find the total of the first 10, and a method mark for adding them together and then dividing by 30 to get the 22.34. Here we are. So those are your 6 marks, and there's an exclamation mark there. Then we come to the final question on the paper. The diagram below shows where Levi wants to attach a string of lights to his house. Levi wants to attach a single string of lights from B to A and then from A to C. The diagram below shows the measurements Levi has taken. He spends £410 at the electrical store buying a string of lights. After putting up the lights, Levi finds he has 6 meters of the string of lights left over at one end. How much did the electrical store charge Levi per meter for the string of lights? Okay, so what we've got here is he wants to put the lights there, and then he's got this 6 meter string that's left once he's gone from B to A to C. I'm looking at the diagram, I'm seeing right angle triangles. It's the last question on the paper. It's got to be trig. These 2 little dashes mean that they're the same, so that side of the right angle triangle is the same as that side. So if I can work out AC, I'll also know AB. I know that the angle is 52, and that is 2.5, and this is what I want to find out. So hunting back now to my formulae, I need to label my sides. That's the hypotenuse. This is the opposite, which means that is the adjacent. So I'm looking for the link between A and H, which is the cos triangle. And what I'm trying to find is the hypotenuse, so it's going to be the adjacent over cos. So x is going to be the adjacent over cos. X is going to be 2.5 over cos of the angle, which is 52. I can type that into my calculator exactly as I've written it. So it's not inverse now because I'm using an angle, so it's cos, sorry, no it's not, it's a fraction first of all, 2.5 on the top, and on the bottom cos 52 close bracket. So that is 4.0606 ... They're measuring to 1 decimal place, so I'm going to measure to 1 decimal place, which is 4.1 meters. So that now gives me enough information to work out what the total length of lights that Levi bought. So total length of lights will be 4.1 plus the other side plus the 6 meters he's got left over. So 4.1 plus 4.1 plus 6, 14.2 meters of lights. So the total length of lights is 14.2. Has that answered the question? How much did he charge Levi? No, it doesn't answer the question. So I know he's bought 14.2 meters of lights and they cost him £410. So to work it out per meter, I need to divide the £410 by the length that he bought. So 410 divided by 14.2, £28, and for my answer there, 87 pence. Now depending on how you round that, the mark scheme basically allows any answer there that rounds to 29. So if you'd have said, well, that's 4, so I've got 8 plus 6, because they wouldn't give an answer in centimetres, that would be a measurement of a part meter. That would also be fine. So for that, there are 2 marks for the trig part of that to get you 4.1. Then there's the method mark for adding all of those together plus the extra 6, and an answer mark of 14.2 or whatever rounding you've used, and then a method mark for working out the cost per meter, and a final answer mark for that. So there you go. That is the final question on the second half of that intermediate numeracy paper. Hope you found that useful.